What we'll do is we'll look at these slides, and then we'll transition back in to the slides from your book. Now, some of you got really great handouts. I made ones that had like the 6 per page, and the copier must have gotten jammed after I left and set it to print, so I didn't have enough. So Hal made some more copies. And so many of you, you might have something where you've got like 1 slide per page, which is really cool, which makes it easier to see. Yes, back here. I'm sorry? You need a copy? Do we have more? Come on down. I'll get you one. I'll get you set up. All right, so that is our gift to you, those extra slides. So let's talk about advanced queries. You need a copy too? I got some more business for you over here, huh? So let's go back and talk about that research paper database. And we're going to look at other databases and talk about some things that apply to advanced queries. We're going to look specifically right now just at the client table, the charges table, and the payments table. And what I first want to do before we talk about how to fix the many-one-many relationship, I want to make sure that we're all clear on what the difference between an inner and an outer join is. Because the inner and outer join operations are independent of the whole idea of the many-one-many concept. And I don't want you getting the impression that those two things are connected or tied together. So these are the 3 tables we're going to look at for a couple of minutes. If we were to run a query using an inner join operation, and we were going to use the client and payment tables. Let's say I asked for the client ID from each table, since it can be found in both of the tables being used. First name, last name, and amount. The QBE grid also shows you that I'm going to sum up the amount. This would be the resulting dynaset. It's kind of interesting, because it will look different if we use an outer join. With this particular join type, you will notice that the resulting dynaset, I have included client IDs from both tables. And that's an important thing. I really wanted you to get a sense of what was going on in that foreign key field of both tables. When you pull the same named field from 2 different tables, notice how Access presents it. Client.client ID. That means client ID field from the client table. Payments.client ID. So you're seeing the client ID field from the client table and the one from the payments table. First name, last name, sum of amount. I've totaled up or subtotaled the amount, so that field is now called sum of amount. Those entries that you see, for every single one of them, there is a matching entry found in the client ID field of both tables. And it matches. So you would see that the very first entry has the same client number from both tables. And none of these entries is blank. It's because Access is listing those records that had matching entries in both tables. So you would expect to see matching entries in the foreign key values of both tables. Anybody who is a client but hasn't yet made a payment gets left off. That's what an inner join operation will do. What about the outer join operation? There were 2 kinds of outer joins. One is relative to the primary key side of the relationship, and the other is relative to the many side of the relationship. In this slide, we're talking about the outer join relative to the primary key side. So if we were to use an outer join between clients and payments, and notice that the relationship line between the 2 objects changes. It appears now to be an arrow pointing away from the primary key table, which is the one that we're asking to get all entries from. Again, I've included the same fields that we saw before, just a different join type. The results look very different. Notice that we see a lot more people showing up on this list. And it's not because some of the people had multiple payments. We've summarized, so nobody's repeating at all. And what we see in the foreign key field of both tables, the client ID from both tables, is that there's an entry for every single person listed when we look at the client ID from the clients table. We've asked Access, give me all the clients from the clients table. So there's an entry for everybody. But in the payments table, there's some entries that are blank. Those are the people who have not yet made payments. And we also see that where it says sum of amount, people who didn't have a client ID that was found in the payments table, they also don't have a sum of amount. That information was not included. It wasn't in the payments table. outer join relative to the many side of the relationship, in this case the payments table, and that looks a lot like what we've seen before, looks a lot like an inner join. In fact, if you flip back and forth between your slides, this looks almost exactly like what we got with an inner join, with one exception. What's the exception to this? What else is here? It's an access, give me all the client IDs that you find in the payments table, match it up with corresponding information from the clients table. What's here that was not in the inner join? All right, Grant Vanderright, where are you? Yes. What do you see different about this Dynaset? Anybody want to help them? Do you have the slides? Look back and forth between them. What'd you say? There's less entries in this one? Actually, there's one more in this one. What is it? Back here. Yeah, that very first entry. Well, you know, Access is telling me, guess what? I found a client in the payments table, and I don't see that client in the clients table. That's our little orphan. That's our little orphan record. That's somebody who made a payment, and we don't know who the heck they are. They're not in the client table. That's a violation of RDI. And that's the most common reason why you'll see this kind of an outer join. The outer join relative to the many side of the relationship, most common reason why you'll see it used to find violations of RDI. Might even see that kind of question on a test. All right, so inner, outer joins specific to the question that you're asking. And I've given examples as we go through some of the questions. How would you change this to be an outer join, blah, blah, blah. We'll get more practice at that next week, too. We have another in-class exercise to do. But at this point, we're going to transition to the many-to-one-to-many relationship. And the outer join operation will be something that we do to try to help fix the disaster that is the many-one-many relationship. But the outer join is not something that's only used in those situations. That's why I wanted to introduce it to you first. You can see it in situations where we only have to use 2 tables in a query, because we're also going to use it here, but that's not the only reason why it would be important. So let's talk about these 3 tables again. Charges, client, payments. Let's say I need to run a query, and I need to get the client information, name and ID. I want to get the total charges, and I want to get the total payments. Because frankly, I'd really like to send out statements to all these clients to tell them whether or not they still owe me money. Because some people have paid all their charges and some haven't. So I don't think it's that unreasonable for me to want to generate a query where I figure out what do they still have due. Some people have nothing due. They've paid up their charges completely. But some people haven't. And I need to let them know I'm aware of it and I want my money. But to do that, I would need all 3 of these tables. And when I do that, alarm bells should go off in my head. Oh my gosh, I've got to run a query. It needs 3 tables. I need to check the layout of the relationships before going any further, because this may be a query that is doomed to fail if I try to do this in one step. So everything would have to stop for a minute. You'd need to check it. And if it does turn out to be a many-to-one-to-many relationship, we're going to have to do something very different. And the quick and dirty way of looking at this would be, if I've got 3 tables up there, or 4 or 5, doesn't matter. If I've got the same foreign key field holding together 2 relationships, I got myself a problem. And that's what's going on. So between charges and client, foreign key field is client ID. Between client and payments, client ID. I'm saying the same name twice. That's about 95% of the time an indication that I have myself a problem. All right, so let's say I ignored myself. I said, self, this should be a problem, but I'm going to do it anyways, because I don't believe Michelle. I don't believe myself. Put all 3 tables up in the design view window. Let's say we leave it as an inner join operation. And I ask for the client ID, first name, last name, and then the amounts from both the charges and payments tables. Now, first of all, let me tell you what your results should look like. And what I've done, and this may seem like a lot, but I've put the tables right on the same slide so that as I show you the screw-ups, you can get an idea of why it's happening. So having that those data tables there helps to be able to identify what's going on in the resulting dataset. So first I'm showing you what the results should look like. These are the results, and this is something you're going to want to hold on to for a minute. Notice that we have charges for everyone listed. It is possible that someone could be in the client table but not yet had any charges, but at this point in time that hasn't happened. And then anywhere that we see a blank spot, that is someone who is a client, has brought us a paper, but hasn't yet made a payment. So these numbers are correct. I'm telling you that. You can double check it. Otherwise, you can just trust me as we move on. That's what should have happened if we got the right answer. This is what really happens if we run that query the way I had it set up in the design view. Very, very different results. And there are two huge problems with these results. The first problem, and we've already talked about this, those numbers aren't right. You can double check it with what you see in the slide before. Now the numbers are right for a few people, but it's wrong for others. So Nancy's numbers are wrong. I think her first sum of amount, and that first sum of amount represents the charges. I put that right above it. The field names are the same. So in order for you to distinguish, the first sum of amount is charges, the second one is payments. For her, the sum of amount from charges is triple what it should be, and the payments are double what they should be. Some of the people have the right numbers. So if you're spot checking, I've said this before, if you're spot checking, you may miss that there are some huge problems here. That's problem number one. What's the other problem with this? Yeah, the numbers are screwy. If you go on this to figure out who still owes you money, are you missing anybody? Hunter? All the people who haven't made a payment yet. All those people who have brought a paper in and I've done work for them, but they haven't paid me, they're not on here. So if I use this to generate my statements, I think those people who haven't made payments are all paid up. And that's a bad idea for me to assume that. What's happened with an inner join operation with three tables, especially in the situation of a many to one-to-many, Access is going to list only those client IDs that are in all three tables. So if a client is in 2 out of the 3 tables, Access doesn't care, leaves it off. If they're in 1 out of the 3 tables, Access doesn't care, leaves them off of the dynaset. They'd have to be in all 3 tables to show up in the resulting dynaset. So anybody who is missing from the payments table, essentially that'd be the only place people are missing from right now. Those people aren't there. And so I think they're all paid up. Right, well, you've seen that. You've seen that there's a problem, but why? You're dying to know why, aren't you? Isn't that why you came back today? Said there's this huge problem in Access, and Michelle promised she'd tell me why it's happening. I'm going to keep good on my promise. I even gave you notes, so you'd be able to hopefully take this home and look at it again if you really want to do that. So when I tell Access that I need to use 3 or more tables in a query, Access has no magical way to go in and automatically pull all the related records from all 3 tables simultaneously. Can't do that. It has to pull 2 of the tables out, kind of generate this intermediate dynaset of just the joining of those first 2 tables, and then match that up, join that up with the remaining table. So here we have the 3 tables, charges, clients, and payments. Access might take client charges out first and generate an intermediate dynaset. Or it might take client and payments out first. So what I'm saying here is that it doesn't matter which 2 tables it takes first, and you don't even see this happen. You don't even see it. But I'm telling you it doesn't matter which 2 it takes first, because it's going to generate an intermediate dynaset and join that up with a table that hasn't yet been pulled from. So it looks like this. Let's say that I have all 3 of those tables in the design view window. Access pulls these 2 out first, client and charges. Behind the scenes, it's doing this. I can't see it to even critique it. And I'm still using the inner join operation, by the way. So Access goes in, and it gives me this intermediate dynaset, which is the joining of the first 2 tables. So notice I have people listed. I see the amounts for their charges. But something's not right here. I showed you the QBE grid of what it's supposed to be doing. What's Access not doing that I told it to do? Look at this intermediate dynaset. What's it not doing? Yeah, back here. Yeah, it's not summing up the amount. I told it. I showed you the QBE grid, didn't I? You can see it in your slides. I told Access to group by and sum, and it ignored me. It said, I don't care what you want. I'm not doing that here. I'm going to group by and sum in the final step, and you're going to be happy with it. And it doesn't do it. So then it takes that intermediate dynaset, the joining of the client and charges table, and by God, it joins it together with the payments table. Now, I don't know if you can see the problem with this. I see it. But then again, I've worked with this a little bit longer. These two objects, Access is using together in the last step of what you can't see. And just like if you were to pull two tables up in the design view window of a query, you'd better see a line between them. The same thing happens when Access pulls together two tables, generates an intermediate dynaset, and joins it up with the remaining table. It better have a relationship. It doesn't. So what's happening is, even though I've told Access to group by and sum, it doesn't do it in the intermediate step. So that, and this is the same thing you saw before, intermediate dynaset, payments table. Access makes a line between them anyways. That goofy program, it doesn't know what it's doing. It says, well, I got client ID over here and client ID over here. There must be a relationship between these two. It's not legitimate. Client ID is not unique in either of these two tables. This is a many-to-many relationship. Access doesn't care. It does it anyways. That's where the problem happens. So when Access tries to join up, so Nancy Zavolio shows up twice in the intermediate dynaset, Access says, all right, let me take that first entry of Nancy. In fact, I show you some arrows in an earlier slide. So where do I join this up? Because I see a J7500 here, and I see one here. In fact, there's even one here, too. Access doesn't know what to do with it. So it joins this record up 3 times. It triples the payments. And then when Access goes back and it tries to generate the payments, so here's the first entry of J7500. Access finds 2 matching entries over here. This is where the trouble happens. All that because Access didn't listen to me, and it didn't group by and sum in these intermediate steps. There's no legitimate foreign key field. So the 2 problems that we saw, crazy numbers, double, triple, quadruple what they should be for some people. Some people's numbers are right. The other problem was that not everyone is showing up. So what I'm going to tell you is, and some of you may be thinking, what about if we used an outer join to fix this problem? Would it help? And the answer is a little. So if I were to use an outer join operation, meaning that in the design view window of this query, so it's essentially still the same query, the only difference is I'm going into both relationships, I'm double-clicking on each one, and I'm saying, give me every record from the client table. Give me every record from the client table. So making an outer join relative to the primary key side of the relationship in both situations. I now see everybody, even if they haven't made payments. That's a relief. I've just eliminated one of the problems. But I still have crazy numbers for some of these people who are listed. So many to one to many relationship, doesn't matter what you do with it. Doesn't matter what kind of join type you use. It doesn't matter how you try to write a criteria. Doesn't matter if you stand on your head. It's not going to work in one step. It's doomed. Absolutely doomed. So the good news is you're smart enough. You're finding out now how you can predict this problem so that you can work around it. Bad news is you've got to know what you're looking for, and that can get confusing. Let's look at another example of using 3 tables together in a query. As I said to you that you have 3 tables or 4 tables or 5 tables, you have to stop and check and see if you have a problem. Well, here's an example of a situation where we don't have a problem. Here we're going to use the client table, the payments table, and the payment method table. The relationships here are a little bit different. In fact, right away, hopefully you look at this, you see 3 tables being used, and you recognize that there are 2 completely different foreign key fields. One is client ID, and the other is method ID or payment type. Depends on which table you pull it from. So two completely different foreign key fields. And if you go in and summarize each table based on its relationship, the client table gets summarized as a 1. It's the primary key side of a relationship. Over in the payment method table, all the way to the end, that's a 1. Well, it's got the primary key side of the relationship between payments and payment method. The middle table holds both of the infinity or the many sides of the relationship, and we summarize it with one symbol. So the middle table should have an infinity symbol underneath it. And that is known, not very creatively, as a one-to-many-to-one relationship. It also doesn't matter what order you put the tables in. So if I put the payments table first, the clients table next, and then the payment method table, it would be a many-to-one-to-one. It doesn't matter which order the manys and the ones are in, just that you have 2 ones and 1 many. So far, so good? But why does this work? You don't want to just take my word for it, do you? I could be trying to trick you. So these are the 3 tables. If I had to use all 3 of these in one step, maybe I needed to get the client ID, the client name, the payment amount, and maybe the method type. Access, in its uninfinite wisdom, has to pull 2 of the tables together and generate that intermediate dyna set, right? You've seen this. It's a rerun. Once it does that, it can take that intermediate dyna set and join it up to the last table. So it doesn't matter if it pulls client and payments first or if it pulls payments and payment method first. It doesn't make a difference. We're going to pull client and payments first. Access, even if I tell it, group by and sum, it still tells me, no, 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 no. I'm going to do it in the last step. You'll be fine. So the intermediate dyna set with an inner join is going to give me everybody who has made a payment. Now with an outer join, it would give me everyone even if they haven't made a payment, which just depends on what I want to get out of this. But notice that the client IDs are repeating. They're not unique, just like we saw in the previous example. So nothing gets summarized here. However, it doesn't matter because in the next step, Access is going to take this intermediate dyna set and join it up with this remaining table. And guess what? There's a legitimate relationship here. There's a foreign key field relationship that's real. So there's a relationship based on the payment type in the intermediate step and method ID. Method ID is unique here. Doesn't matter how many times a payment type repeats in that intermediate dyna set, Access knows exactly where it belongs in that payment method table. And it works. So even if you didn't hear a word I said, all you heard was blah, 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 like I'm from the Peanuts gang, what I want you to remember is that with a one-to-many-to-one relationship, you can do that in one step. The many-to-one-to-many, even if you can't remember why it doesn't work, you just need to remember it doesn't work. So now let's go in and take a look at the slides that are from the book. I want to say page 171. And once somebody gets to page 171, tell me if it looks like that. It does? All right, good. I've got a better memory than I thought. So one of the first things that I would like for you to do with this slide, besides look at it, is to change where it says for all clients. I mean, it should, in yours I think it says all employees. Please change that to all clients. This part of the lecture deals with fixing the many-to-one-to-many relationship. We can't solve the problem in one step. We're going to use 3 steps to do this. For those of you who really like Access, as I cover this, you might think to yourselves, I think I can do this in 2 steps. And you'd be right. So we kind of take this a step further, only because it seems like a process that's more easily learned. And I will next week, as we look at the in-class exercise, even talk just a little bit more about doing this in 2 steps. And kind of that depends on how many of you get that. In some semesters, I've had students who really, really catch on to that and they like it, whereas other times they just close their ears and they don't want to hear another way to do it. So I'll kind of gauge that. But I'll show you 3 steps, but if you're thinking to yourself already, we could do 2 steps, you're right. So what we're going to do is do what Access did, but do it right. We're going to take 2 of the tables together at a time. And we're going to make sure that we use the totals line. We're going to make sure we group by and sum. We're going to make sure that we use an outer join so that everybody, every client appears, even if they haven't made a payment. And even if, God forbid, we should have people who are in the client's table, but they haven't even had charges yet. We want to make sure we capture all of those. So this is the set of steps that we're going to go through. I'm going to do this in Access. You're going to have these notes right in front of you so you know what I'm talking about. So, same database that you've been seeing. I've got the same tables here. What we're going to do is create a new query, and we'll pull 2 of the tables together. So let's kind of keep this consistent with the examples that I just gave in the slides. Let's pull client and charges together first. And I'm going to pull in the client ID, last name, or first name, last name, and amount. Okay. Now what I want to do is show you exactly what Access does when it screws things up. If I don't do anything else to this query and I simply run it as is, this is the same thing that Access does right before it screws everything up. This is the intermediate dynaset that hasn't been summarized. This is the intermediate dynaset that has repeating client entries. That's now going to be joined up with the payments table, which has repeating entries. You don't want to redo that same fatal mistake, right? So you're going through this whole process for a reason. One of the most important things you have to do is use a totals line. Right? Now no one repeats. Now, client ID is a primary key field of this query. And we have to be thinking like that. If you're writing a query and the expectation is you're going to use it in another query, you're going to act like it's a table. What are you going to do to join this object up with something else if you need to? Client ID is unique. Now, the other part of this that isn't quite so obvious in this step, because we don't have any clients who haven't made charges, but we will look at databases where that's not necessarily the case. In each of those first 2 steps of the multiple step query, you also want to change your join type so that even if you had clients who haven't made any charges yet, they will also show up. So you want to make sure it's an outer join. So in these intermediate steps, the most important things you can do is, first of all, don't use all 3 of those tables together. And the other thing that you have to do is make sure you're using the totals line. And lastly, make sure you're using an outer join so that you can account for everyone. I'll run the query. Now again, we don't have anybody who hasn't made any charges yet. What I'm going to do is take a picture of this because we're going to use it in a second. Let's close this, and we will call it step 1. Again, very creative, right? Step 2, we're going to take client and payments, and we're going to do the same sort of thing. Client ID, first name, last name, amount. And really, I don't even need the first name and last name in here. Right now, I'm just trying to keep this all as consistent as possible so that I'm not confusing the daylights out of you on the first example of this. Making sure I'm using the totals line. Now, if I don't use an outer join, I'm not going to be including everyone. And that could really cause me some big problems in the last step. So here it's a little more obvious why we need to change that join type. Now, one of the things that I've mentioned, but I want to make sure that you've heard this, that you understand this, when I use an outer join operation, if I need the foreign key field in the results, so the foreign key field is client ID. It's just a matter of whether I pull it from the table where it's the primary key or the table where it's not the primary key. With an outer join operation, relative to the primary key side of the relationship, I need to pull client ID from the primary key side of the relationship. So with outer joins, it does matter where you pull your client ID from. If I pull it from the payments table, I'm not going to be seeing all of the clients, even if they haven't made payments. I run the query, which we've done. And what I want you to imagine is at this point, when we move forward, we're going to be using these two queries as tables. So what you have right now is a query. In a second, we're going to pull this table in and this table in. These queries will be used as tables. So let's make some observations about it. Do we have a legitimate foreign key field between these two objects? Yeah. Client ID is unique here. Client ID is unique here. Client ID is going to be our foreign key field, and it's unique in both of these objects. So this is what you have moving into the last step. So let's do that. Turn that volume off. Close this, and we're going to call this step 2. In the last step, smack your hand if you try to go in and pull up the tables you just used. You went through all that trouble for a reason. You're going to click on the Queries tab. Your tables are really the queries that you just made. So step 1 and step 2. Hold this up. You have to form the relationship. Access is not that bright. Hopefully you've come to know that by now. But that mechanical aspect of me just drawing the line is simple, but the confidence behind that of knowing there's a real relationship there is the important thing. So I can draw a line between anything. You've seen that. So at this point, let me ask you a question. So let's say what I asked for would be the client's information by last name and first name only, and then I wanted to figure out what their total charges are, their total payments are, and the balance due. I didn't ask you to include the client ID in the last step. Would you still need to include client ID in those 2 steps? So if all I asked you for the set of results is to show the clients by last name and first name, I didn't ask you to show the client ID, would you still need to use the client ID in the first 2 steps? You guys want to know a secret? If you actually did some head nodding, I'd be less likely to start calling out people randomly. And anytime I look up, I find a bunch of people look down real quick. They don't want to make eye contact with me. And then that makes me have to walk over here. So if I just see somebody go, yeah, I'm less likely to go, come on, talk to me. But somebody saved you. Over here, yeah. Why? Yeah, just in case 2 people have the same name, it all goes back to unique entries. I still have to have some unique way of combining these 2 objects. So even if I didn't need client ID in the last step, in the final grid, I still need it in those first 2 steps because it's the only way I can connect those 2 queries together. So heck yeah, I'd still need them. You're absolutely right. Let's say I do want the client ID, though. I'll throw that in. It doesn't matter which table I pull it from. It makes no difference whatsoever. First name and last name. I mentioned to you, you don't have to include first name and last name in both steps. I just did to keep it consistent. The sum of the amount in the first step represents total charges, and this represents total payments. But I got to tell you, when I go to look at these results, I just don't know if I'm going to remember that. And we can see that, again, in the situation where we have 2 fields with the exact same name, Access has to put in the object that they've come from. So step 1 dot sum of amount, step 2 dot sum of amount. I don't like taking chances with that. I'm going to go in and rename those fields. In order to get these field names to show up, if I wanted to use those in the expression builder, I would have to make sure that I save this first. But I'm going to do this without pulling those through with the expression builder. I'm going to put it up here so you can see it better, but I'm just going to type out the expressions. So I'm going to call this expression total charges, colon, bracket, and this needs to be step 1. I have 2 objects that have sum of amount in them. Bracket around sum of amount. colon, bracket, step 2, exclamation point. All right, so we're not done yet. I didn't write my calculation. I'm just right now trying to make this a little bit clearer about what I'm using. I am going to close this and go back in. Let's call this step 3. Bet you didn't guess that one. All righty. And now we're going to generate the expression. And for this, I'm going to take total charges minus total payments. All agreed that would tell me how much somebody still owes me, right? Yep. Thank you. Got some head nods. I appreciate that. And let's call this balance. You can call it whatever you want. You can call it I hate CSC 2111. I don't really care. And this. Now, one of the things I want you to notice is that Nancy's numbers are right. It's not 700 and 750, right? We fixed that problem. Everybody's showing up. But I'm not patting myself on the back yet. Why? If I look just at that balance column, first of all, I would be a little surprised by the fact that I have so many people overpaying. That's kind of odd, don't you think? Maybe they just expect they're going to be coming in routinely throughout the semester. They don't like typing their papers. But the other thing is, I have a lot of people that still owe me money, and I don't see anything in the balance column. That's a problem. Because now I've got to go in and do that calculation myself, and I don't want to have to do that, or maybe I don't. What's happened is that when Access sees a field that's blank or null, N-U-L-L, that's a fancy word for null in Access, Access doesn't assume that that null space is a 0. It assumes it's like a big black hole and it sucks everything into it. So in this case, when I tell Access to take $200 minus a null value, it makes another null value. And the same thing with 100. 100 minus a null value, that gives me another null value. So null values propagate themselves throughout the entire expression. I don't want that to happen. It's not working for me here. There's a way to fix this, though. And if you look at the very last part of the Access slides, let's bump ahead. I don't know what page this is on, but it's just a few pages ahead. It talks about the NZ function. The NZ function is kind of like a really cool if statement, but shorter. And it says, Access, if you look at this field and you find a record that's null, can you stick a 0 in it for me? And if you don't find any null values, just leave it alone. That's what an NZ function is. And there are two parts of the NZ function. First is called the variant. It's the field that could potentially have null values in it. The next part, the value if null, is what you want Access to do if it finds a null value. You want to stick a 0 in it, right? So those are really the two pieces of the null value formula. So let's use this. Go back in. Now there are a bunch of different places where we can fix null values. I could fix them here in the expression where I change the field name for the sum of amount. Typically, what I do with null values is I fix them in expressions because null values really aren't problematic until we try to use them in an expression. So those null values that were showing up in the sum of amount fields, those weren't really bothering me because I knew they meant 0, right? It's when I put them in an expression and Access doesn't know how to include them in the expression. That's when there are problems. So I tell Access to fix that. I say, okay, let's go back and look at this expression. And we are going to account for the possibility and the likelihood that somebody could be in the client table but not be in the charges table. There's a very real possibility that we could have some null values with total charges. If you use an NZ function around a field and it never ever contains a null value, it will not be problematic unless you write the function wrong. So the NZ function is an if statement saying if, Access, if you find a null value, stick a 0 in it. So we're going to use NZ. Next part is to open a parenthesis. The variant is the field that contains or potentially contains null values. That would be total charges. After the bracket that closes off the field name for total charges, I put a comma, a 0, and I close off the parenthesis. Now, you may be wondering, why didn't I just stick a great big NZ function around this expression? Because it doesn't work that way. Any field that potentially has a null value in it has to be dealt with individually. Each and every field with a null value or a potential null value in it has to have its own separate NZ function around it. Otherwise, all I'm telling Access is, if the expression evaluates to a 0, don't leave it as a null answer in the cell. And that's not the same thing. So minus NZ, open up a parenthesis. The variant is the field name with the brackets. Bless you. Comma 0. Close the parenthesis. Now, I do want to tell you that comma 0 is technically optional. So by using the NZ function, if you don't put in the value of null, theoretically Access assumes that it's 0. Let me tell you what I think about Access and all the theoretical stuff. Sometimes it doesn't work right. So I've seen situations where, yeah, Access is supposed to know that I mean stick a 0 in it, and it didn't do that. So you will always, almost always see me putting in comma 0 in my NZ functions, even though technically I could leave them off. So you will see that somewhere in the book that, yeah, they're optional, not really. All right, so now let's run this. Woohoo, look, we got numbers for everybody now. Questions so far? Yes. Oh, the negatives that you see instead of the parentheses around it, it's just a formatting. And actually, some people might be saying, well, I really don't like the fact that it doesn't look like currency either. And I wouldn't like it. So if I go in back into the design view, right-click on the field and select Properties, I can make this a format of currency, rerun the query. With the currency style, the parentheses are what identify negative numbers. What else? Oh, great, I've got enough time to show you another example, so let's take a look. So let's close that out. That was our last step. We got the right numbers. We got everybody to show up. Now let's look at a new database. It's not really that new. We've seen it before. We've seen this, the accounts, the deposits, the withdrawals. So we've got our bank database. Account holders are here. Deposits, they're here. Withdrawals, well, you get it. They're here. And then we do have account types that identify the different types of accounts people could have in the account table. And in addition to that, there is a field called monthly fee. So some of these accounts cost money every month for people to have them. So let's think about this. Let's say I wanted to run a query. Let's pull up our relationships. And I wanted to generate account balances for all my customers. And I'd like to get every account holder, and we have the beginning balance in the accounts table. Let's imagine that that field represents the account balance at the beginning of March. And here we are getting to the end of March, and we need to figure out what the balance is at the end of the month. And in the deposits table, let's imagine that we have all of the deposits for the month of March. Even if they spanned further than March, maybe they went back into February and January, we'd simply use a criteria to make sure we capture just those dates. But that's what I really want to focus on is the many, one, many right now. And over in the withdrawals table, we can get the total withdrawals, and we can subtract that from the beginning balance. And then this account type with the maintenance fee, we have to also make sure that we're subtracting out that monthly maintenance fee, right? That's what our expression would look like. Beginning balance plus the total deposits minus the total withdrawals minus that monthly fee. We have a many-to-one-to-many relationship here between deposits and accounts and withdrawals. Many, one, many. And it doesn't matter if we throw in the type table, it's not going to help. It's just going to be a really big mess. So whether we have 4 tables, 5 tables, 10 tables, if we have deposits, accounts, and withdrawals anywhere in there, it's a mess. Can't do it in one step. So let's use the same sort of strategy to fix this. What makes this example just a little bit different is that we're throwing in that types table. We could go in and run one step where we pull deposits and accounts, use an outer join, group by and sum. The next step, accounts and withdrawals, and do the same thing. It's pulling in this type table that may throw some of you off. And the truth is, I can pull the type table into either of the first two steps, and it would be just fine. In fact, if we just focus right now on withdrawals, accounts, and type, these three tables can be used together in one step. So between withdrawals and accounts, the many side of the relationship is here. So the withdrawals table, you'd summarize that with one symbol. It would have a many symbol. The type table is the primary key side of the relationship. It would get a 1. The accounts table, interestingly enough, holds both a primary key side and a many side of a relationship. So the accounts is both a 1 and a many at the same time. When you summarize a table like this, as long as it holds a primary key side of the relationship to the other table being used, one of the other tables being used, you could summarize it as a 1. So this ends up being a 1 to many, which is the same thing as 1 to many to 1. Doesn't matter what order they're in. So these three can be used together at one time. In fact, these three can be used together at one time. Accounts, deposits, and type. Same situation. Type table is a 1. Deposits is a many. Accounts holds both a 1 and a many. So we can summarize it as a 1. So what I'm saying to you is we can use type along with deposits and accounts. We can use type along with withdrawals and accounts. We cannot use type along with withdrawals, deposits, and accounts all at once. So anywhere that these three tables are together, it's doomed. But if I yank one of them out of there and use just these, it works. It's all because of the layouts of the manys and the ones. Yeah? Why is there what? That's a really good question. She's noticing that I don't have the many. Whoops, that's interesting. I don't have the many symbols showing up on the lines between type and accounts and withdrawals and accounts and deposits. And the reason is because I used this same example last time to show you violations of RDI, and I never went back in and fixed them and enforced it. So that's why it's not enforced. And I also didn't know if anybody was going to ask about that. So some of the databases I have, I don't have any violations of RDI in it, but I always leave this one in here because it's always interesting. If I go in and I show you that there are actually people who have withdrawn money and they don't have an account, it's kind of a startling thing. So that's why. So if I went in and I enforced RDI, you'd see those symbols showing up, but I didn't simply because I do that with this one. I think I have another copy of this since you've asked. I can't remember. No, I don't think I don't know if I have that with me in here. I could look for it, but I don't know that it would make much of a difference for some of what we're doing today. Yeah, I don't know where it is, but that's why. All right, so now let's take a look. Where was I? Okay, so now what we're going to do is look at setting this up. We'd have to do two tables at a time, but in one of the steps we can throw in that type table. So we can do this in a couple of different ways, and this is where people tend to get a little frustrated with Access, even if you really liked Access at first, because of the fact that when you get to these multiple step queries, there are a variety of ways that you can efficiently and effectively handle it. It tends to make people feel really uncomfortable. Let me put it to you this way. There's a lot of variation in how you can do this right. The one thing you never want to do when you're dealing with a many to one to many is in any of the steps, try to use those three tables with the many one many relationship in it. So as long as you're not pulling those three in at once, most of the variation is pretty benign. So let's take a look. Let's pull accounts and deposits. Now again, I could pull the type table in here if I wanted, because it's not going to cause a many to many relationship. So I could get that whole account monthly fee pulled in right away if I want. But let's not put it in the first step. So remember, the things that we need to do in the multiple steps, make sure you change your join type to an outer. Make a checklist for yourself. You're always going to be doing this. Very, very few situations where in a multiple step query, you're not going to want to use an outer join in the first two steps. So account number, last name, first name, beginning balance, amount, and you also have to use the totals line. If you don't use the totals line, you're doing the same goofy thing Access does. So when you run this query, you should expect to see none of the account numbers repeating, everybody showing up, and their numbers should be accurate. And these numbers are accurate. We close that, and let's take a picture of it so we can remember it when we go to that last step. We're going to call this step 1. And in the next step, so in this step, let's pull in the type table. Now, one of the things that I do want to talk to you about, when you have 3 tables up here in the design view and they're safe to use together in one step, sometimes you need to change the join type for only one of the relationships. So I'm asking Access to be sure to include all of the account holders, even if they haven't made any withdrawals. But I do not need to change the join type between type and accounts. I'm not asking Access, oh yeah, and also make sure you include all of the account types, even if no one has opened an account with a specific type. So that means this other join, just leave it alone. So account number, we can pull in last name and first name again. You don't have to, though. Amount, and then the monthly fee. One of the things that you're going to notice, not in the pre-lab, but perhaps in the in-lab, I can't remember if it's this coming week or the next week, when you have 3 or 4 or 5 tables up in the design view window, in situations where it's safe to use them together, when you have to change the join type for one relationship only, like we do here, we only need to change between accounts and withdrawals to an outer join. The other join can easily be left as an inner join. It's not going to cause any problems, but in really rare occurrences, and this is not easily predicted, so please hear me. You would never have to know this on a test on paper. This would be something that if you're in lab and you see this happen, you'll see the error message, you'll go, oh yeah, Michelle said that. You'd never have to predict this on paper. I can't even predict this on paper. But sometimes when you change one of the join types to an outer join, Access gets just crazy about the remaining join. It can't chug the expression. And it'll give you an error message that starts out by saying ambiguous outer joins. And it's an ambiguous error message, by the way. And in that error message, Access goes on to tell you that you need to perform a separate step, force the evaluation of 2 tables first, and then use that in this step. Wouldn't we have been really happy to get a message like that with the whole many to one to many thing? Access says, hey, you can't do this in one step. And it puts it in this, a query like this, where you can chug the expression in one step, and it's not correct. These are things that you have to know. These are down and dirty facts of using Access. So if that happens, you've got more than 2 tables in a query. They're safe to use in a step, so it's not a many to one to many relationship. If you change one of the join types to outer, normally you don't have to worry about the other join type if it doesn't need to be changed. You just leave it as an inner. But in rare circumstances, you may get an error message that says ambiguous outer joins. When that happens, open up the join that you didn't think you had to touch and change it to a 3. And it'll run. That's something you only need to know for lab. All right, so anyhow, so we're changing this to the outer join. Run the query. And this isn't one of those ambiguous outer join examples. But I wanted to mention that in case you see it. If you do something wrong, too, it's just at least nice to know why you're getting that message. All right, so this is one of the tables that we're going to use in our final step. Here's the other table. So we have account numbers. Oh, what did we do here? I got so carried away. What did I forget to do? Yeah, I forgot to sum. That would have been potentially messy. Now, what the heck? Oh. I mean, it's not really that funny, but it's kind of funny. The amount is what I'm trying to sum, not the monthly fee. There we go. All right, now we've got account number is unique, account number unique, so that when we pull these two steps up in the design view window of the last step, we've got a legitimate relationship. So this we will call step 2. And query design view. You are not going to pull tables usually. So step 1 and step 2. And you make the line because you know it's a valid relationship. Doesn't matter where we pull account number from if we need it. Let's say we don't need account number. I just wanted last name and first name. It also doesn't matter where I pull last name and first name from. I didn't have to include last name and first name in both of these steps. Let's just pull it from the first step. Here's our beginning balance. Here's our sum of amount, which represents deposits. This represents withdrawals. And this is the monthly fee. Now, I'm including all of these in my QBE grid just so you can kind of see the progression when we get our answer. It's possible that on a question like this in lab, we may just ask you for the last name, first name, and the account balance. And you wouldn't have to put all these fields in the QBE grid simply to use them. I'm just doing that so it's easier for you when we get the results. You can go, oh, yeah, that looks right. Yeah, that looks right. That doesn't look right. So it makes that a bit easier. So let's pull the expression up. Expression builder. We're going to use the queries. Here's step 1, beginning balance, plus the sum of the deposits, minus step 2, sum of amount, minus step 2, monthly fee. Now, when I hit OK and I run this, you should be expecting that this may not work out as well as I thought, right? We would not want to see any blank spots for anybody. Frankly, we've got somebody with $90,000 and she only withdrew $3,500. There should be some money in that account at the end of the month. So there shouldn't be anything that's left blank in here. It's those null values. Anywhere that we had either a total deposit or a total withdrawal missing, Access could not chug the expression. Now, typically, you're not going to see blank spots or null values in fields that were created in tables. So normally, I'm looking through the beginning balance field. I don't see any blank spots. Monthly fee, I don't see any blank spots. And the reason for this is when you're working with databases, if you have fields that contain currency or numbers, you plan ahead. You think, all right, if this is going to be a field that could be used in a calculation, which would be the only reason why you would give it a field of currency or number, you would not want somebody skipping over the field without entering something in. That's how null values would happen in naturally existing fields within tables, would be if you didn't make the field required and somebody could leave it blank. So in the properties, you'd make sure you always make it required, right? If it so happens that you know that you have some null values within fields in the tables themselves, not things that you've created from outer joins, then you would have to put NZ functions around the fields from the tables. But at this point in time, I'm telling you, we know that we see numbers here. I'm telling you, when I constructed those fields, I made it impossible for somebody to leave it blank. The only place that we have to worry about null values would be those fields that were generated from outer joins, where I told Access include everybody, even if you couldn't find an amount for someone. So it's the fields that we constructed with the outer joins that will potentially have those null values. Those are the ones that we need to fix. So we'll pull this up with the expression builder, and with the sum of the amount, which represents the deposits, we're going to stick an NZ function around it. Comma 0. And step 2, NZ, open up a parenthesis. At the end of the bracket for amount, I can't tell, there we go, comma 0. You could, like I said before, you could fix those null values in these steps. Well, first of all, in step 1 or step 2, you could have put an NZ function around the expression. You could have fixed it here or here. I usually just fix it in the calculation where things are already a little bit messy to begin with. So, what you should know for the pre-lab, if you haven't already started working on it, work on it as soon as possible. It has a really great example of a multiple step query, and it walks you through it. So it says, hey, guess what? In this question, you're not going to be able to do it in one step. It'll tell you how to walk through the process so that you can mechanically do it. Now you know why you're doing it. In the in-lab, you should be ready for another example of a multiple-step query. So the more practice, the more time you work on this between now and lab, the better. There are some also great examples in the course notes book. Oh, one other thing. Come out of your book. In this textbook, the course notes textbook, there's a section with an access supplemental text that our previous course coordinator wrote. And some people have found it very, very helpful because it helps to explain some of those more complicated things in access. Did the extra slides help? Okay. Now, there are some other databases that have outer joins and multiple step queries in them. They're on the syllabus, but just a reminder, there is the Antique Car Club, the Employee Database, Conference Database, and Web Services. All of those, great practice. And we're also going to have an in-class exercise next week so that you get a lot more practice with this. Questions? Yes? The accounts table to connect them? Because they were already connectable. When I go back into the design view, account number is unique in step 1 and it's unique in step 2. If they weren't unique and I pulled the accounts table in, I'd end up having a many-to-one-to-many relationship again. That's why.